Super excited to be doing this, Patrick. Thank you so much.
Thanks for
Ex-
having me.
yeah, excited to be doing the first live stream and super excited to be getting into the nitty gritty details of Avalanche. I got really interested in Avalanche through my good friend Laura. And ultimately, she inspired me to go to the Avalanche conference and met a bunch of awesome people, and eventually got put in touch with Kevin, and through that kind of snowballed all my interests. Had a really awesome conversation with Kevin and kind of breaking down Avalanche from first principles. But I would love to kind of start this podcast and conversation with you, just a brief background on how you got into crypto. I know you were at Coinbase for a little bit, but then kind of what got you excited about crypto, and then what got you excited about Avalanche?
Yeah, sure. I'll give a brief introduction here. I actually grew up in Wisconsin, so pretty far away from the tech scene in general. I growing up there, I actually didn't know anything about crypto at all in the Midwest. And then when I came out, I went to Stanford in 2014 is when I first got involved with it. So at that time, that fall, there was actually a class taught by at that time biology, which was pretty funny.
Nice. That is funny.
I think it was called CS 251P. So it was kind of this side class just about Bitcoin, and everyone took it because you got a free 21 miner. So if you've
Nice.
ever seen one of these, I'm trying to figure out how to make it fit. It's like a Raspberry Pi with an ASIC
That's cool.
built on top of it.
Nice.
So I've had this on my desk now for the past like 8 years or something, just as a reminder of like where we've come from and what
Yeah,
sort
that's
of stuff
amazing.
like that. But so they had this huge, shipment of stuff there. So I did that class, learned a lot about what was going on in Bitcoin at that time, and I was just totally enamored with it. I think the joke I always tell is at that time at Stanford, there were three things you could do. It was either AI, rockets, or crypto. And I tried my hand at AI. It didn't really go very well, and crypto and distributed systems always made sense to me, and so I just stuck with that. So, I learned about it there. I think my faith wavered after the first crash in like the 2015, 2016 a bit, but in 2017 went in full on really getting involved with it. And after Stanford, went to Coinbase. I took a leave of absence to, play around with different crypto projects at that time. So I actually took a 2 week break from school, went to Coinbase, went there, worked there for about a year and 9 months or so on a project on the crypto engineering team called Rosetta, which Coinbase uses now to add assets to Coinbase. That was a lot of fun through that process. Got to meet a bunch of amazing crypto teams at that time. So added a bunch of assets to Coinbase in the process. And then through that, really just started to deepen my opinion on what projects I really wanted to work on. And at that time is conveniently when Kevin reached out to me on Twitter asking if I
Nice.
had heard of Avalanche, and the rest is kind of history. But I left Coinbase in the beginning of 2021, took a 1 day break, and then went to Ava Labs. So I left Coinbase on a Wednesday and started at Ava Labs on a Friday. And then yeah, have been here ever since. So
Beautiful.
yeah,
Beautiful.
it's the brief history. But now when I go home, people that hadn't heard of crypto at that time are all like, should I buy? Should I do whatever? Should I? And my rule is never to give anyone advice to buy crypto
Exactly.
because if they're
Exactly.
asking me if they should think about crypto, it means that they should go into crypto.
Yeah.
It takes more conviction than that. Yeah.
Yeah, I made that mistake in the 2017 bull market, and I did not repeat that this time. So definitely some learning lessons each cycle. But awesome. No, I appreciate the background. Well, let's just dive into it. You're currently the VP of Engineering at Ava Labs.
Yep.
In your words, how would you kind of describe Avalanche, and how does it make it different from other kind of layer ones in the space?
Yeah. I mean, I think L1s right now are, I think, I certainly am not a history major, but one of the more competitive landscapes I think I've ever seen, at least in recent history for sure. And it's interesting where you have a space where the users or the typical people that use it are pretty much wholly unaware or uninterested in the underlying mechanics. And
Yeah.
then every single project has war chests in the realm of like hundreds of millions of dollars to compete directly. But at Coinbase, before I made the move to Avalanche, I got a chance to really dig deep into a number of of the common projects at that time and some of the ideas that were coming out. I think around then there's a lot of hype around Telegrams, like Tom project, if you remember that, with like the
Hmm.
whole like 3D blockchain stuff and everything. But um, Avalanche to me, when I left and really wanted to do it, I had a few really high conviction opinions that matter to me when joining a new project. One of them, first thing, was just speed to finality. I think so much time and effort and like UX has been put into handling finality that takes on the order of minutes or even like on the order of tens of seconds to make it feel like an actual web experience for people. And Avalanche was the first project I saw where finality was really as fast as it felt like on any other web service I'd ever used. And so for me, finality was the first thing that really brought me to Avalanche. But typically, other projects that sought the same sort of finality made compromises elsewhere, either by increasing or decreasing the validator count in some meaningful way. So, like, okay, yeah, you can achieve crazy finality with 5 validators, right? Or by like kneecapping the virtual machine they were using so that it was, you know, not composable, not, in some way interesting for a lot of different applications. And Avalanche had 3 different virtual machines that were all running at that finality rate that had very different properties. And so for me, it was a question of, finality, distributed participation and consensus. So like how many participants are there? How many people that can actually produce blocks? How many people can, generally participate in consensus? And then basically an expressive virtual machine framework. Whether or not that was the actual virtual machine or on subnets, you can create custom virtual machines. Both of those check the boxes for me. So, when we talk about Avalanche, it's both the consensus as well as the platform. And so I kind of had clear interest in both of those. And most people that come to us, I think, to work at Ava Labs, see the consensus and want to dig deeper and work on something that they have found very interesting just because of how different its properties are from a traditional, PBFT approach.
For sure. No, I think one of the things that always kind of caught my attention about Avalanche was the ability for the subnets to have the custom virtual machines. I always thought that was fascinating. So let's kind of break apart some of that. You mentioned fast finality. Ultimately, what kind of enables that on Avalanche, and why is it pretty fast compared to like other traditional layer one blockchains in the space?
Yeah. So, I mean, I think first off, I'll talk about really how it works, just to kind of give people a sense
Perfect.
of what the consensus mechanism is in general. And then I'll go into some of the ways that, people may consider doing different parts of it separately. So first off, Avalanche Consensus is a repeated subsampling protocol. There's this awesome website. If you just search like, I think it's like Avalanche Simulation by TED, which is the most like visually captivating thing on the one of the most things I just go back to always, and I can just sit there forever and just keep replaying it. But the idea is instead of having a more deterministic consensus protocol where like you have a participant that proposes a block and then all the participants or some supermajority of the participants sign some payload, return those signatures to the proposer, and then that block is somehow distributed to the rest of the network. Instead, how it works is participants will just query each other, or what we call poll each other, asking what their preferences are with data that they've seen. So very simply, let's say that I have a group of 20 people, and I say, "Hey, like, what do you guys think of the stuff you've seen?" And then they return back what's called a chit or their vote of what like their current preferences. And so the node then, that's doing this poll or this process says, okay, do I have, what we call alpha over K votes within that poll? And if so, that's considered a successful poll. So like, okay, in this case, maybe 15 out of 20 people agree that a certain transitive dependency exists. Like, great, that's a successful poll. And then I'll do that again and again and again until I have so many successive polls in a row for the same value. And once that happens, it achieves finality. Now, the typical parameters for that are like, 15 successive polls in a row of success sampled of everyone in the network. So the big difference is that on a traditional consensus, let me back up. In Avalanche, it's all about subsampling.
Mm-hmm.
So you don't ask everybody what their preference is. It turns out that if you just ask a small portion of the network, and everyone does that again and again and again, you actually have the whole magic of Avalanche is that leads to this like emergent property of like really quick basically alignment, and then the nodes based on what they're hearing and the preferences in the network will start to shift their preferences to what the majority is. And
So if I
so
could just repeat it real quick, ultimately, because I mean, you're not querying all nodes, you're just doing the small subsampling, they're able to achieve consensus faster, ultimately kind of having quicker finality for transactions more
well,
holistically.
strictly speaking, like the network complexity is less because you have to deal with less people, but there's a few properties that come out of that I'll explain, I think, why it's faster in general. One, we issue those polls in parallel. So you don't have to like issue one wait. We actually issue like four at once and then process them when they come back in order. So first of all, you have this like kind of parallel consensus process going on with just network layer stuff. Secondly, we perform authentication with each other in the initial handshake so that when you're actually voting for something, you don't actually have to sign anything. You just respond on a mutually authenticated TLS connection. So there's no overhead of like different cryptographic properties that require you to sign it. And then lastly, there's no hotspots. So in other systems where there's a proposer, that proposer is in charge of like collecting all the votes and then putting them on the block and then sending it out. Additionally, during that, they typically have to send the entire block for you to sign. And then you have to send back that signature. In Avalanche, instead, how it works is someone just proposes a block and then you start voting on it on your own. There is no like central node that collects all the signatures or collects all the votes and then tells everyone what happened. Instead, everyone just determines for themselves with their own parameters if they choose what is valid. So there's this like kind of there's not necessarily the step where they have to send all this data to everyone. They just kind of do it on their own whenever they get it. So
That makes sense. And so, from the user perspective, ultimately, I mean, going that was from like the more technical standpoint. From the user perspective, ultimately, what is the user experience derived from like all these technical innovations?
yeah, so I mean, for most people, what that means is like you send a transaction on most people interact with the C chain, and then it's confirmed, within and the end-to-end finality is in the realm of like 2 seconds. So transaction gets included in the mempool, mempool's gossip to some validator includes it in the block, and then finalized. So that whole process, on average, we have a lot of like telemetry and metrics of this. Takes about 2 seconds. So once the
Gotcha.
block actually like a validator actually proposes a block, it's finalized within 750 milliseconds or so.
Nice.
But the end-to-end latency requires kind of a pre-step, and so
Yeah.
that's I'm sure that we can spend a lot of time talking about future optimizations of different things. And I think the mempool is one area that a lot of other projects have gotten a lot of interesting results from in recent months, and something that we're definitely going to dive deeper into over the next few months as well.
Awesome. No, I think that's a great walkthrough. Ultimately, so with the subsampling, you're only reaching out to a couple nodes. How long does that kind of finality, or it is final, as you mentioned, in a couple seconds? How long does the subsampling or finality take to propagate to all nodes?
Well, so that's the thing is there is no actual propagation of the finality.
Okay,
So every node on their own runs the consensus protocol and determines finality when they choose.
I
So
see.
now this is a very interesting thing that we don't really talk a lot about. But when you run Avalanche Go, you can specify what your consensus parameters are.
I see.
And then you alone determine that. So for different partners, for example, let's say there's an exchange that's like, hey, like I'll tolerate up to 5% Byzantine node failures. And I just want to, against like every possible heuristic, optimize for safety. Like I want to be past 33% safe. I just want to like sit there and only wait for like a hyper super like clear preference in the network.
Yeah.
Maybe I'll say instead of doing like 15 out of 20 in a poll and 15 consecutive, I'll do 19 out of 20 with 100 consecutive. And so you'll finalize slower because you're performing many more polls, but you
Mm-hmm.
can kind of configure your own safety parameters, which is super weird and interesting and totally different. It's kind of like the way with Bitcoin you determine your finality, like your confirmation depth of like how long you'll wait for a deposit.
Hmm.
In the same way, you can kind of have this configurable safety when you're running Avalanche nodes. Now, what that means typically is like these are just standard messages between each other. Like there's no overhead, right? So like a typical round trip between two validators takes about 150 milliseconds.
It's quick.
So, and that's just network. That's not us, right? That's just
Yeah.
standard networking
Hmm.
packages in 2022, right? It's pretty fast. And so you just do a simple round trip and then you process, polls in parallel. Because if you're sampling a huge portion of the network, typically your polls don't really conflict at all. Not that that really matters, but you can just sample more people and then typically get to finality faster. So,
And
yeah.
for most networks, they're not doing the subsampling, and the network communication overhead is n squared. What is Avalanche's network communication overhead with subsampling?
So the theoretical side of it is logarithmic, which is why we say that the validator set can grow much larger.
And
And
so,
now the reason for that, right, is like let's say that you have a traditional consensus system. You have a block. That block is then you create it. You then distribute that block to everybody in the network, right? All validators for their signature,
mhm,
and then they send that block back to you. And then that rotates.
gotcha. And the key difference there is they're propagating it all to all, which kind of makes the n squared overhead in Avalanche with the subsampling is ultimately able to reach out to fewer nodes, and in doing so, able to come to consensus faster and have the faster finality.
Yeah. So like let's just say in one simple example, right? So it's a two-part thing where there's no bottleneck on a single node that's kind of like running this process, and there's no cryptographic stuff that must be returned for the block to be shared. The second part is, yeah, like let's just say in a simple case, right? You do 20 polls, and you query 20 people in each of them. That's like 400, back and forth, right?
Yeah.
We have, you know, 13, 1400 validators. So like even in the case where you're doing these repeated subsampling, in the best case or like even in the average case, you're touching a small fraction of the entire population, which
Nice.
is just a super interesting property in general.
Yeah, no, I do think it's from being able to go from n squared to logarithmic is a big accomplishment. Um,
Yeah.
Ultimately, I think so. There's multiple chains, as you mentioned, on Avalanche, and I think this is often kind of a big misconception as well. A lot of people just fully focus on the C chain. Could you talk about the different or the overall architectures, and then kind of
Mhm.
dive into some of subnets as well?
Yeah. Yeah. So I'll give a little primer here. I think the first thing you should note, right, is like, first of all, like, great, that's a really nice property to allow that many validators. But there's a reason for that outside of just like the decentralization of the system, which feeds into the subnet story, which is if you have all these validators that are part of the primary network and you want them all to run their own validators on their own subnets that are still part of the primary network, you need to be able to support a lot of validators.
Yeah.
Otherwise, the subnet story that's connected to the primary network won't work very well. So there is an immediate like capability that we have because of the way that Avalanche works that enables much more interesting kind of subnet architectures in terms of number of participants and the way that they can all fit together. But I'll get into that a little bit later, I think. So yeah, the Avalanche is broken into what we'll call like almost like two tiers. There's the primary network, which is we call the primary subnet, or really what all validators participate in. So most people, this is what they touch. If you're validating on Avalanche, you're pretty much just validating the primary network. If you're using Avalanche, you're probably just using the C chain, which is one of three chains on the primary network. Now, people are like, well, why is it designed that way? First of all,
Right.
and then on there's a P chain that's like the staking chain, so that's not embedded into the C chain, for example. And then the P chain determines how subnets work, like the membership in them and rewards on them. And so the P chain then governs all these subnets that are loosely connected, but to be
Yep.
on a subnet, you have to be a validator of the primary network, right? So people are like, yeah, there's a lot of complexity, especially when you're starting off, right? So let me back up. And I have to say, preface this by some of these decisions. I think, you know, I didn't come up with these ideas. So like I joined a little bit after mainnet launch. So I have to say like a lot of the ideas and some of the brilliance of what we're trying to do here is not my doing, but I'll do my best to recant it. So on the primary network, if when a new blockchain launches, it's typically a really slow uptake. Because you have a whole new virtual machine, a whole new framework. You have to build new explorers, you have to build new wallets, you have to work with all the integration partners, right? At the time Avalanche launched, obviously there was huge interest in the EVM and what you could do with it. So when Avalanche was created, there was a desire to get what was needed in there for the subnet story, which was the P chain, but then also to provide a easier virtual machine to interact with, or a more popular virtual machine to interact with smart contracts, in a place that didn't require people to create subnets from day one.
Yeah.
Because if you already only have like 200 validators on Avalanche, it's a lot to ask to like start to like really split things
Yeah.
up. And so for an initial growth story and to get people's attention, the EVM was added initially. Now, the unintended consequence of that, I think, was that everyone started calling Avalanche like an ETH clone, Geth clone,
Yes.
whatever have you. And don't get me wrong, we're super indebted to the work of the Ethereum Foundation and the Geth team and all the stuff they've done, just like a lot of other projects that support the EVM are. But people, I think, at that time failed to kind of understand that like it's a VM running in a subnet,
Yeah.
primary subnet, on top of an entirely different consensus, entirely different storage, entirely different everything underneath. Um, and so, over the last, really since that time, we've been working on improving performance and then shoring up all the systems for the launch more of the subnet story. But people then also ask, feel free to cut me off at any of this, but the other part I think people tend to ask then, the immediate follow-up is like, cool, I get it, right? You have this primary network that has all the validators, and I get you have these subnets, people can do their own custom virtual machines with their own tokens, with their own everything, right? But why do they need to validate the primary network? And because it's like, Cosmos doesn't need to do that. Like
Yeah.
zones are all independent and they kind of connect to each other. And to that, I would say with the current feature set on the network, I can totally understand why people would say that, right? Like the subnets don't benefit in any way from knowing, at least right now, about like the membership of other subnets, like what's happening on the primary network. They just kind of care about themselves. So people are like, well, maybe I could fork Avalanche Go, rip out everything, just run the subnet module, and then, kind of be on my merry way. And I think that'll all make sense when the cross-subnet messaging protocol.
I'm super excited to talk about the cross subnet stuff. Maybe
Yeah.
on like the ETH stuff initially. So the main C chain is a instance of the Ethereum virtual machine, the EVM. Ultimately, you have and the team have done lots of improvements to speed that up. But the main, I would say, like that is, as you mentioned, kind of how you guys kind of bootstrap the network, but ultimately going forward, the real kind of not innovations, but like one of the key benefits of Avalanche is being able to create your own subnets. And in those subnets, or how would you describe a subnet? I asked Kevin to describe it, but I think it'd be awesome for you to have it describe it in your words, and then maybe kind of like the pros and cons of like an
Yeah.
individual subnet as well.
Yeah. So, I mean, subnets in a sense are just some subset of Avalanche primary network validators. That's it. That subnet has the validator set is controlled by the P chain. And the reason for that is any node that joins the network then knows who's participating and who they should reach out to if they want to discuss.
Mm-hmm.
But subnet itself, on the proper term, is just the validators that are participating in some group. And then on a subnet, you can instantiate any number of chains. And a chain is just an instance of some virtual machine. So, for example, this is why I come back to the primary network, right? The primary network is just a subnet with 3 chains from 3 different virtual machines.
Mm-hmm.
Most popular subnets, like DFK, for example, are a subnet with their validators on it with 1 chain, which is running an instance of a virtual machine we call the subnet EVM, which is basically a forked version of Core ETH, which is derives a lot of stuff from Go Ethereum. And so you could, for example, add multiple EVMs to a single subnet if you wanted to. But the hierarchy is very much like you have a group of validators, that's your subnet. The subnet then can have multiple chains. Those chains are just instances of some virtual machine or binary. And that is communicated with Avalanche Go. And so it just handles all of the management of all these virtual machines kind of running concurrently. So in a sense, it's almost like a little mini like container runner or
Yeah.
like like almost like a Web3 version of AWS in a sense where like you have a subnet that like runs all these random virtual machines that are user generated, and then all Avalanche Go provides is a consensus plugin. So the interface that a VM gets is like, hey, here's this blob of bytes, parse it as a block, tell me if it's valid. Okay, you think it's valid? Now verify it. So execute what's going on and make sure the state transitions are correct. And then the consensus has been says like accept or reject. And then, outside of that, you can do whatever you want, right? Like you want to define the blights however you want, good to go, but I don't want to get too ahead of ourselves in terms of just
and,
subnets. Yeah.
And going back to like the user application standpoint of this, what ultimately the subnets allow is a lot more customization, because you can customize the virtual machine and then you can have your own individual subnet if you would like. So you can tailor that to whatever needs you desire.
Yeah, I mean, I think a lot of people talk about this where like, there's a lot of different approaches now to, trying to achieve some form of scalability while, balancing that with the ability to customize different parts of the experience, right? So if you do want to provide all your own validators and maybe you want to provide your own security, which some people, have a lot of interest in doing, a subnet's a really good option because you can determine the native fee, you can determine the state transition rules, it's really, if you can compile it into a binary, technically it'll work. So like that's your constraint.
Yep.
And I think in some other cases, there's much more strictness on terms of what you can actually do and like what things you have to have. And our whole purpose with Avalanche Go, or really the goal, is what's the lowest level interface we could provide for people to build or like run binaries for some point that borrows some form of networking consensus. And one thing that we're really excited about providing is a more opinionated SDK that sits on top of that, so that when someone's thinking about, okay, I want to create my own chain, it may be like, cool, yeah, I can do it from scratch. But if I don't want to, like, is there some great form of tooling I can use to build on top of? And I think, the Cosmos team has done a great job with Cosmos SDK, Rapid Tendermint. I think we would look to do something similar with like, an included database and included, account management, included, signature verification, because we've rewritten that almost every time that we've done our own virtual machine. And so it'd be great. I understand the creator's question when they're like, yeah, like, do you have a thing that keeps track of balances? Like, well, kind of. So
yeah. Awesome. Cool. Maybe just to wrap this kind of like overarching conversation of Avalanche up, and then we can get into some of the new things that you've just released. What, in kind of your words, I think there's still like two main like kind of focuses of scaling today. One is kind of more the modular architecture that say Avalanche and Cosmos are trying to pursue, and then the other one is still like the monolithic architecture. Could you like compare and contrast those in your words, and why like Avalanche has specifically chosen to go the modular route and why it thinks it's advantageous?
Yeah. I mean, in my opinion, I think it all comes back to a single shared state. I think generally speaking, if it was possible to have one massive state for every possible computation, anything anyone was doing, that'd be ideal, right? Like imagine infinite composability and everything right there. But we know that that's been a bottleneck so far, managing like a single state that large and updating it accordingly, like having a canonical state across, one large virtual machine.
And what would be the bottleneck in that instance?
So most times people that have that large of a state, are trying to, authenticate it, or not authenticate it, but as much as like hash it, or like have a Merkle tree or some sort of tree or some sort of hash that represents its current state. Maintaining that data structure on top of an ever-growing state ends up being a really, really complex thing to do. And people are doing a lot of cool stuff to improve that and, maybe do different approaches to it. I think Peter Schlage from the Get team had a fantastic presentation he did at DevConnect this year, where he talked about the inherent bottleneck just in trees in general, with how they're, how they work with databases and how they work with blockchains in specific. So to paraphrase him, think of it this way. You have a tree let's say that's some level of depth that represents the state on your project, even with the best stuff like a path-based storage, Merkle tree, or anything. If you want to modify, let's say, 2 accounts and you have a huge tree, okay, and each tray node is persisted to disk.
Yep.
So let's say that they're just on 2 separate sides of the tree. Let me see if I can get my
Yep.
image,
Yep.
right? And they're on 2 different sides, right? Let's say that it's 7 layers deep, and you modify one, and then you modify an account on the other side, right? You'll have to rewrite 1, 2, 3, 4, 5, 6, 7 nodes on one side if you're hashing the nodes all the way up.
Yeah.
If you're not doing path-based, right? But just traditional, this is what people traditionally have done, where you hash each tray, and then if the tray node changes, you rewrite it. So 7 and then 7 again. So that's like more or less like 14 reads and 14 writes to do one simple transfer, right? So the overhead gets kind of crazy as you start to manage these ever and larger trees. So like, is it possible to have a huge state? Yes, but to authenticate it in an interesting way so that other people can state sync up to it is a much more difficult challenge that I think people have really glossed over in a sense. So a lot of new work has been going to like, okay, if we're doing path-based storage, like, can we store things more efficiently for this and stuff? But at the end of the day, if you're generating a root hash of all the state that's going on a block by block basis, which is what most projects do. Some have started to do periodic batching to like reduce this overhead, and that's what people tend to do. But you have a lot of overhead of just maintaining this structure. So like a breakthrough in this sort of space would be huge for everybody. But generally speaking, a large composable state has a premium. It's more expensive. And so if you have many parallel states, so like in the case of like horizontal scaling with subnets, you have tons of tiny little spaces rather than one massive space. And because of that, you can kind of remove some of that overhead depending on what's going on, and you can kind of tune things accordingly. So the way I think about it is, yes, in an ideal world, would it be great if we just had one monolithic chain and monolithic state that everyone could access at any time? 100%. It would be fantastic. But if you want to minimize the burden for individual validators to participate, and then make sure that they only maintain the minimal amount of state necessary, and then within that, each subnet or chain or whatever like that only has to like kind of hash in for any activity only the stuff it cares about, you can start to save in general across the entire board on the system. So the thing you give up though is the composability, right? Like, okay, now if I want to interact between 2 subnets, you just made that way harder than the way it was if you just had one single state. So I think the real question in the next couple of years of blockchains will be, does that play out? So, I think Aptos, Sui, Solana are pursuing like the whole view of having a single state. And then you have, the Polkadot, the Cosmos, Avalanche that are pursuing, this like kind of heterogeneous state story. It'll be really interesting to see what ends up being the approach that captures most of the mind share.
No, I'm fascinated as well. The state definitely does get very large on those chains, and then it is a lot of historical data as well. So I appreciate
that's a whole nother aspect of it, right? Is like, okay, you can keep the state required to validate, but then the archival thing, factor 100.
No, it does get it gets pretty difficult. Cool, but I appreciate you breaking that down and comparing them. Let's talk about some of the new stuff Avalanche has recently launched. You have recently kind of written, the Avalanche team has posted a new Medium post kind of outlining a lot of the changes that you guys just published to the network. Could you walk us through what those are and the results of them?
Yeah. So I think for the most part, this has been something that we've been looking forward to probably my entire time I've been here. So it
feels good to ship.
It's so like, I think before I hopped on this podcast, I think 5 minutes beforehand, I clicked the button to ship the mainnet release code. So
nice, congrats.
I wanted to get that done before this so I could focus just on this. But I won't mince words and say I think this is the biggest release from a functionality perspective that we've ever put out.
Congrats.
And why I say that is very simple. So when the network originally went out, subnets were out in a simple form, more or less a proof of authority form. And a lot of people are like, oh, subnets are cool and interesting and stuff, but they're controlled by a single individual, and that individual determines who can be a validator on that subnet. So for example, a lot of the popular subnets, right, have some form of a control key, or like, let's say just an administrator of the subnet that determines who can become a validator. And is this the final vision we had for like all subnets? Like, fuck, like, of course not, right?
Yeah.
Like, and people are like, wow, subnets, like cool stuff, but like it just falls short of the vision. And to us, it's like, oh, God, it really just pushes us further to get something out. So
Yeah.
the vision obviously is that anybody at any time can like launch their own full network, really as a subnet on Avalanche. And to do that, you need to have proof of stake validation. So in the most recent release, we released something called Elastic Subnets, which adds permissionless validation and rewards to subnets, which means that if I wanted to today, or at least in 2 weeks on mainnet, but today on testnet, I could create a token, create a subnet, and then require that people have to stake that token on that subnet to become a validator. This is all run by Avalanche Go. So you as a this is some of the stuff we do, right? Like if you're running a virtual machine, you don't even know that this is happening. It's not even a part of what's going on. And then you get rewarded if you're up for some percentage of time on that subnet. All of this is handled externally to the virtual machine. So when you're launching a virtual machine, you can do literally anything. And then as long as you're up, you can get rewarded. So let's say that you wanted to generate like a blockless virtual machine, or like a P2P virtual machine that just did like periodic gossip, and you wanted to keep track of people that were online and then reward them for that. The system will now, can provide that capability. So for us, it's like a whole, quantum leap in where Avalanche can go now. Now that it's totally open. So in a sense, for people that, maybe aren't familiar with some of our terminology, it's the equivalent of, let's say that you, previously you were the one that controlled all the tokens, and then you staked all the people that were going to participate. And that was how it worked.
Yeah. Now
you can kind of distribute the staking token or the weight, and then people can validate as they see fit on the subnets.
Very cool.
And so we haven't, because it's been such a large thing and we've spent so much time on it, we haven't had enough time to prepare all the cool tutorials and documentation. I can assure you that's coming very soon, but we're very excited to see this kind of out the door. And for the astute reader, you'll find that the transaction that we added to enable this includes an argument for a BLS public key. And that should maybe play our hand a bit in terms of what we are seeking to do. But from a protocol perspective, we are now unblocked from the cross-subnet story a little bit more.
Nice. Congrats. No, that's a big accomplishment. It always feels good once you ship something, get it out the door. So congrats again. And so the main, could you maybe just like re-articulate in like 1 or 2 sentences, like from the user perspective or the node operator perspective, again, why this is such like a big accomplishment?
So on Avalanche, you can now stake on multiple chains at once and get rewarded for that.
So multiple different subnets.
Yeah. Gotcha. So let's say that you're, an astute astute validator, and you're like, hey, I want to generate, I think, let's say, I'll give you a very simple example. I'm a validator. I tend to think I'm a good validator, right? Yeah. And I think that I could use my, experience validating to help other subnets get off the ground and then be rewarded for that. Well, in the past, I would have to go to that subnet and say like, hey, like, I'd like to validate. Do you trust me? Like, will you add me as a validator? Which is like the whole point of crypto, right? Is this is not necessary. So, but that's how it used to work. Now I can just go buy up, or do whatever I want with some of the token related to that subnet, and then just stake it, just like I would stake on any other network. And I can now participate in that subnet. Yeah. That's huge. Like, there's no way that we go from, us double-digit validations on a particular subnet into the hundreds or thousands without actually providing the true like proof of stake functionality. So We expect in the next few months we'll see subnets rapidly decentralize and have much larger validator sets and everything.
Nice.
So yeah, we're I think we're very we pay attention to what people say, right? And I think that generally a lot of the critiques of subnets thus far has not been their speed or the performance or anything like that, but it's been, you know, cool, but there's only like 10 people validating it.
Yeah.
Like, does that bother you? And so the answer is, yeah, of course it does. Everyone would love to see more, but the mechanism for adding that, I don't think has been there, but now it is.
Nice.
And so
Awesome.
I think, as we add more functionality, the clear benefit for users is you can now stake or delegate on subnets, which can make subnets way more interesting for the people creating them.
Mm-hmm.
And then secondly, your funds and everything you do on that subnet will be basically protected by many more validators. So.
Awesome. Very cool. Awesome. Maybe moving the conversation a little bit forward. One thing when I was speaking with Kevin was talking more about like the virtual machines and kind of exploring the design trade-offs and different kind of world of what are performant virtual machines. It's kind of been interesting now, just even like this last year, seeing like Ethereum kind of be, and it still is, like the most dominant virtual machines, but people continuing to explore like more parallel processing virtual machines. Could you talk about Avalanche and its ability? I mean, we spoke upon it initially, but to create custom virtual machines, but how you guys are kind of thinking about the virtual machine space in Avalanche.
Yeah. So for me, I think there's a lot of aspects of the custom virtual machine story, whether it's technical or actually like more organizationally and kind of resiliency. So I think the one thing that I think is super underappreciated about the way custom virtual machines work in general and being able to deploy them on subnets is it's much easier for us to iterate on all sorts of interesting virtual machine designs without actually like impacting a production network.
Yeah.
So for example, if I had a monolithic chain and I wanted to totally change the way something worked, sure, I could do all my testing and do everything. And at some point you have to launch it, right? So you put on a dev net, you put on a test net, right? That takes a lot of effort to do that and make sure it doesn't break, right? Like, because if you try something and then like, oh shit, doesn't work, like, people lose their shit. They're like, it's not stable. Everything you guys do is a joke, right? And so you have to be really careful. With subnets, you can take the exact same virtual machine framework that you may run on, the mainnet or on your subnet, spin up a subnet, try it out, like get people to use it, do whatever. And then if it doesn't work, you just forget about it like it never happened and start over, right? So at least from the inspiration of like what you can do with virtual machines and subnets, it's huge for developer productivity. Now, people may not realize because we haven't really talked about it publicly, but we will in the future, some of the stuff we're doing on virtual machines, right? So initially, most people have seen that the common virtual machines on Avalanche are just EVM variants in some way. That's again not really our goal or end goal as much as it's just where people are today. And we found that with our current size and everything like that, it was much more efficient for us to just support an existing virtual machine project rather than to like build it entirely from scratch, which is extremely complicated and expensive to do right. But now that we've gotten further along in the story of what we're doing, we have turned our attention back to the virtual machine side. And so we now have a team of quite a few people that are working on Rust specific stuff. And so in the next 2 weeks or so, don't hold me to that. We plan to release the Rust SDK for building virtual machines. And so for people that have been like, oh, I want to play around with subnets, but I'm a big Rust fan, you'll now be able to build your virtual machine entirely in Rust and then run that on top of Avalanche. Because of the way virtual machines work, like I mentioned, with different binaries and things, it's totally separate as if you can compile it, you can probably run it as a subnet, right? But the interface that virtual machines bring about is very low level, like I mentioned. So compared to like I think other virtual machine frameworks, which have very strict ideas of like how you should interact with the state tree, like where your virtual machine may be called during the block production process, ours is much lower level. So instead, you basically the engine will say you parse this block, verify, accept or reject, but then you also have full control of the subnet's networking library. So you can send arbitrary messages between other validators on your subnet for
Okay.
anything. So like, oh, you want to gossip things in a certain way? Like
Really?
send blob bytes. Yeah. So
Hmm.
we haven't really talked about it much, but this is exactly so how we build different things. So like we built state sync on top of this arbitrary blob transport layer exposed in the virtual machine interface. So I think for people that want to build things, we just don't have great documentation or SDKs yet that wrap a lot of this functionality. But if you're trying to build a virtual machine and you want to go like as low as possible, I firmly believe there's like no better place to build than on top of our virtual machine interface because it just lets you do pretty much anything. Like
Yeah.
the gas isn't metered, like there's no compute metered. So like you don't have to like format things in a certain way. You don't have to even use the database provided by Avalanche Go. You could like call out to a SQL database. You could put it in S3 buckets. Like it's totally in your control. All it
So
has to do is just run.
yeah. So ultimately, you can control the networking messaging because of the customization of the virtual machine, and you can design the virtual machine however you want from scratch. And
Yeah.
ultimately, because you can pretty much have infinite amount of subnets, you can be able to iterate faster with many different designs.
Like
Ultimately,
I think I've built around 200 subnets and about four of them exist still to
nice.
give you some concept of what
Yeah.
I'm talking about. Yeah.
Very cool. Ultimately, what do you think the industry will kind of end up in more like parallelized virtual machines, or do you think they'll be more like single threaded? I'm
So I
curious to
mean,
get your thoughts.
so we're working on some stuff internally, obviously, as I would imagine most people are around parallel execution. Because we don't have to, when we start building on our virtual machine interface from scratch, like there's no constraint, right? So you
Yep.
can just start from scratch. So an idea, you can explore, right, is let's say that you wanted like a hyper transfer optimized virtual machine.
Mm-hmm.
In that case, you know all the keys that will ever be touched during block execution without any extra work. Like, from to,
Yeah.
all right, you got two database keys, and now you have 1,000 transactions. During the parsing phase, you can completely separate all the execution out into different compute groups
Yep.
without any overhead and then start prefetching the state. Now, if you have smart contracting, it's obviously dramatically more complicated,
Mm-hmm.
right? Like you have to understand what keys you're going to touch, like do a bunch of prefetching, work. And I think a lot of projects have spent a lot of time trying to figure out the best way to do that. Even the EVM added access lists, which will let you specify the keys that you're going to touch during execution. You get a small discount if you do that, because it will help with stateless execution and everything like that in the future. But I think for me, parallel for a lot of use cases makes a whole hell of a lot of sense.
Mm-hmm.
I think that's not a hot take by any means. I think that with Avalanche and the generic way the VM library works is like you're empowered to build parallel execution environments for your specific use case,
Mm-hmm.
which if it's not super generic, maybe much simpler than super generic like smart contracting engine.
That makes sense. Cool.
Yeah.
No, I've always been fascinated by Avalanche's ability to do the custom virtual machines, and I did not know that you could also do the custom networking. So,
Yeah, the
super excited about
interface for
that.
that, because I've talked to a lot of people that have said the same thing, like, wait, you could do what? So like the way it works is you literally just say like app send and you say the node ID.
Interesting.
And that's the entire interface.
Yeah.
And it just goes. So you don't
Very
have to
cool.
worry about like when I say networking, I'm not saying like, oh, you have to implement this fancy
Yeah.
like send bytes to this person or gossip bytes to all validators.
Yeah.
Those are like your options.
Okay.
So and then you can have like a clear request response, and the Avalanche networking interface will handle like all the request IDs for you, failures, timeouts, all of that's managed for you. So you just have this super simple, what looks like a function interface to say, ask this person for something. Great, I got something.
Yeah.
So it's a really awesome primitive for building really cool P2P
Yeah.
applications. I
No.
call it like almost like the P2P factory, but
That.
it's
Yeah.
really not. There's a lot of branding I think we can do better to make people aware of what you can do with it,
Yeah.
and I think that will come in the next few months.
I,
But
I,
yeah,
I've definitely always been extremely impressed by Avalanche's the entire team technical capability. I think sometimes it is hard for the general population to be able to follow along with like how does the tech ultimately transfer to the user applications, or even like the engineering, like and kind of some of the simplicities that you guys ultimately do. But super excited again about like all the stuff that you guys are doing. Maybe to keep going, how would you? I think a lot of people today are like, or the Cosmos verse just happened, but how would you kind of compare again, like some of the stuff that Avalanche is doing to like Cosmos, or even like a layer 2 or a parachain? Because I think other people also have a hard time understanding the differences and some of the nuances between each of those.
Yeah, I mean, I think by far and away, that's probably the common question we get asked. I think that in the space now, there's such a small number of projects that are really, legitimate and doing really great stuff that the especially like sought after ones get a meeting with all the top folks. They like
Exactly.
hear their pitch, right? And
Yep.
understand like, okay, you hear the pitch of like monolithic L1, you hear the pitch of like
Yeah.
L2, you hear the pitch of, the Cosmos Zone, you hear a pitch of Avalanche subnet, and then you're left to somehow pick what makes sense. And I think for different projects, there are certain components of it that are, really useful. Like for example, if you don't want to run your own nodes and don't provide your own security and don't want your own virtual machine, taking something that's much more polished off the shelf or that provides just a standard execution experience you're used to can be super nice, right? Like if you just want to do what you do on ETH, but cheaper, L2s are great for
Yeah.
that. Like I don't disagree whatsoever. But if you want to build, much deeper applications and use your own token and provide your own security and, run your own nodes that are optimized for a use case, you have to go deeper and you have to take a deeper stab at it. So, subnets in a sense, I think the thing I'll add here is that the way that at a high level, the cross subnet messaging story will work. And the part why I need to tell this is it makes sense to actually compare them when you have at least some understanding of where we're going or what's coming as a part of
Yeah.
this. But simply put, all virtual machines in Avalanche know the validator sets of all other virtual machines.
Okay.
Very simple. Okay. No overhead. It's just provided in the block execution context by Avalanche Go. All that data is stored on the P chain. So everyone knows it for every block execution on every subnet. Straight up. And so if every subnet validator has, a key associated with them, you can trivially verify any message you get from another subnet with no, what I'll call like housekeeping overhead or bookmarking overhead or anything like that. So let's just say very simply, right? Like you're on subnet A and the validators in subnet A use their aggregatable signature to sign something and then pass it along to another subnet. That subnet can, without anything from the other subnet, verify that that message is authentic.
Okay.
No one else does that right now because you have this root of trust that everyone already is aware of and then uses for these like interactions. So you can end up having like a high throughput messaging protocol between subnets that's entirely generic. So, we don't have a standard message format. We don't have any of that. You can just produce arbitrary signatures and then use them anywhere within subnets. So like, oh, you want to interact with subnet blah, 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 that has a totally different virtual machine. If the subnet A knows what it wants, it can send it. We would expect different protocols to implement different messaging standards, probably as a result, but our vision is more the lower level. Like we enable that and then different virtual machines that find it interesting can use it. So to back up and why we're comparing this is that if you have this like multi-zone or like heterogeneous state world, the thing you need to replace composability, if you're not going to provide that as a single state, it better be really easy and fast and quick to interact between the different state zones.
Yeah.
And so subnets, when this is rolled out, will provide that.
Awesome.
And so people come to us and say like, well, yeah, like there is no subnet interop story. There is no, whatever. It's like, no, there always has been. Like subnets as separate zones that don't talk to each other, that just are randomly connected to the primary network, doesn't make a whole lot of sense. Like it's not very coherent if if you think that's our where we've ended up and that's what we're going with, like no, like we have much deeper aspirations for what we're doing. And so subnets, how they compare in that form with cross-subnet messaging to other people is if you're trying to move messages all over the place, um, how they compare, for example, to parachains, where parachains, all the messaging actually flows through the relay chain. Like that's its whole point outside
Hmm.
of rotating validators around on different parachains. There's a lot of overhead then because message passing has to go through there. With Cosmos zones, you have to pass, the relayers have to keep headers in sync on every end of the connection because they serve as light clients of each other. So you have this overhead of passing headers back and forth all the time and then messages on top of that. With subnets and the interop story that is there and will come soon is that there's no overhead. You can just take a message and then verify it just as fast as you can verify an aggregate BLS signature.
Nice. And so without that overhead that is kind of uniquely enabled by Avalanche, what are the properties from the user standpoint?
So for the user, it's like you're on subnet, whatever, and you want to go somewhere else. You can do that in a matter of single digit seconds. So it should be in
Gotcha.
the order of 2-3 seconds to move between subnets.
So it'd be the
With
same type of finality as like a single subnet.
Well, so the way it would take is you wait for finality on one subnet and then you
Mhm.
include that in another. So let's say that if the end-to-end finality on a subnet is 5 seconds, it should take 10 seconds to
Okay.
move between subnets,
Interesting.
fully
Cool.
finalized.
Yeah. And so, and Avalanche's kind of point of view in all of this is just enable that functionality and let third parties be able to come in and create that like subnet to subnet communication, or is Avalanche going to build that in house?
We are going to provide like a useful example of actually doing it. Like it'd be one thing for us to just be like, the keys are there, man. Like good luck,
Yeah.
it works. Just
Yeah.
like we're going to go further than that.
Okay.
But we expect people to have alternate implementations that use the same primitives. I mean, the way we look at engineering at some point is almost like two levels, right? There's primitive platform engineering, and then on top of that, you have what are virtual machines that you can end up building that use all those primitives.
Yeah.
When we develop anything, our main goal is primitives, as many as possible, as powerful as possible, and then leave it up to virtual machines to use those in a way that they find interesting. Because the whole point is like, you know how to build your virtual machine better than we do. We'll
Yeah.
provide you tools, but like the whole point is that we want to enable you to do things that you can't do elsewhere. And so when we're thinking about virtual machines, when we're thinking about comparing to other people, we say like, what do they provide? And typically they have some really full featured SDK, but if you don't use that SDK, it's not possible. With us, we're working on an SDK you can use that has these higher level primitives that are like that's more opinionated, but you by no means don't need to use it.
Yeah. Okay. Very cool. Awesome. We've touched upon a lot, kind of the general overview of Avalanche, kind of the new things that you've launched recently, the differences between like Cosmos, parachains, L2s even, the different trade-offs, subnet to subnet communication. And even I think we touched upon scaling. Is there anything that we've missed out on the technical aspects outside that you want to touch upon?
Yeah, I mean, I think the only other thing I would touch on is I think another question we get is, okay, cool, you have these subnets, but then what happens when subnets hit their capacity?
Mm-hmm.
They're like, oh, cool, you just moved the problem to another place, but it's the same problem, right? And the thing I want to touch on that a bit, which is, our goal with subnets on a performance level basis is not to take inefficient virtual machines and just allow more throughput by having more inefficient virtual machines, which you could
Yep.
do. That would be a cop out. Like,
Yeah.
if I had a virtual machine that just did transfers, but it did like super dumb stuff, and it was only going like 2 TPS, right? Like, and I just made a million of them. Yeah, I could get 2 million TPS, but
Yeah.
like, is that really what you want? Probably not. So instead, our goal more so is okay. Let's optimize the shit out of everything and then have n number of those also
Mm-hmm.
working. So that's our main goal. But then within that, within a subnet, you have this multi-chain primitive, right? So you can have multiple chains within a single subnet. The really interesting thing you can do is because each chain has a separate state, you can actually run each chain on a separate host with separate storage, with separate networking. And so you can actually create Avalanche Go as a cluster
Hmm.
rather than a single binary. So you can scale out not just the consensus processing of a single chain, but then once you're at a chain's capacity, you can scale out horizontally that way so that you have each chain. So that's running on its own host with its own networking. And so
Interesting.
then you only need to synchronize within the subnet for movements between those chains within the subnet, which because all validators are there, you don't actually need to do like a cross subnet transfer or anything. It's just sharing state between them. Like you have a single think of it like a simple key value store between them that they just read out to once in a while.
Yeah.
So what that enables is like, let's say that you're some crazy gaming company. You could have a chain for a region close to you. You could have a chain for like Asia. You could have a chain for, whatever. And then for only certain cases, you could move between those. But then every time you want to launch a new region or launch a new game, you could create another instance of a chain and then put that on an entirely new host or entirely new state store. So that's something that we'll look into like kind of towards the beginning of next year. But I think a lot of the stuff that we're doing will make a lot more sense to people in a span of like 2 to 3 months. I think we've been doing a lot of stuff behind the scenes the last year and a half or so that, I think we're transitioning a bit to be a little bit more public about some of the development that we're planning to do so that people are more aware of what we're actually
Yeah.
up to behind the
Yeah.
scenes. Because we're some, to the credit of everyone on the team, some brilliant people. And I think a lot of the work, it's kind of a weird thing when all your work you've been doing for like a year is not public or no one even knows it exists, right? And then, you see all the stuff people talking about. And
Yeah.
hold us to that. We are very excited to work more with the community and share more of what we're working on so people have a better understanding of, we're very interested in the stuff a lot of people are interested in. I think that our engineering efforts, when they come out in the next few months or so, will clearly indicate that.
Awesome. Well, again, super excited kind of for your recent launch and then ultimately for the stuff that you're continuing to enable. How I would ask, like, I think a lot of people are interested in the Avalanche ecosystem. I'm super excited. I think you guys just announced that you guys are going to do a hacker house in the Bay Area. Definitely really excited for that. Outside of like coming to like this hacker house and future hacker houses, how can people get more involved or opportunities for collaboration with the Avalanche ecosystem?
Yeah, that's a great question. I think we have been working on building out a whole new team to help facilitate, like I think, a better connection with the community. But in the next few months, you can look forward to us kind of opening up a proposal program of sorts for people to like better communicate and kind of discuss different changes that could be made or different things that could be done. Right now, the best way to get involved is to hop in Discord. We have a super active Discord of people suggesting different things, like whether it's virtual machine research or whatever. If you're a project looking to build something and plan to, we always create different like Slack Connect channels between Ava Labs and whatever you're working on to try and support you as much as we can. And then, we have our own like call to action things, which is we would love to create a virtual machine dedicated just to ZK proving.
Nice.
And like, it'd be super cool to work with people on that. We'd love to see virtual machine SDKs in other languages. I think as soon as we ship the Rust SDK, which is like totally defined on its own, it'll be much easier to copy that and create like a C++ wrapper or, I don't, I don't dabble in some of the other stuff, but like JavaScript, Python, whatever you want, right? So for us, the best way to get in contact is do that. And I forgot to plug the Avalanche Creates project, so thank you for reminding me on that one. But in Berkeley, towards the end of October, we'll have an event. This is a new series we're doing where we're traveling around the world, and instead of providing like a really quick hackathon sort of thing, like come in, win some prizes, disappear, never see you again. The idea is to kind of create a rotating, like kind of incubator project, closer to like a Y Combinator than like a hackathon thing. So we'll bring, different VCs in the area. We'll bring different support from Ava Labs and the community to help you get your ideas off the ground, let alone just like kind of technical stuff. Because turns out, as much as I may not like to think so, a lot of doing things in technology requires all sorts of other aspects of legal, like business, like marketing.
Lots of things behind
business.
the scenes. I've been learning that as well too.
Yeah. So for me, or someone that's much more engineering minded, it should be a great experience for people to come and learn a little bit more about what you should think about, or mingle with like-minded folks that maybe aren't as technically gifted but want to support your project in other ways.
Perfect. Awesome. I did just check the chat.
Yeah.
It is live, which is cool. I didn't
Oh,
know if that was
sick.
going to work or not.
Now,
One,
now, now we know.
yes,
Yeah.
a couple questions from the chat, and then maybe we can kind of wrap it up.
Yeah.
It says, "Can you say a word about BSL signatures for those who aren't gigabrains?"
Yeah. First of all, we had nothing to do with their development or their, productionizing in the last few years. So, huge shout out to the researchers. I think some amazing cryptographers. I always joke around about crypto being just like one of the most absurd things humans have ever invented. Like the stuff you
Yes.
can do with it is just absolutely insane, right?
Yes.
And I, for one, I am not smart enough to understand how to develop new cryptography, but I feel like I can appreciate just something really, really cool.
Hmm.
BLS is that. And so BLS is a project, or really not a project, Jesus, a curve of cryptography that lets you do aggregated signature verification. So very simply, let's say Logan and I both have a public-private key pair of BLS. I forget the name of the BLS stands for the people that came up with this, so you'll have to look at that. There's two BLSs actually, so don't get confused. But let's just say we both have a key pair, and we want to show to someone, external to us, that we both signed something.
Okay.
BLS has a primitive where we can basically, let's say I have my signature, you can send me your public key and your signature, and I can aggregate them, slam them together, and then it looks like another just key pair,
Okay.
just a standard public key with signature. So you may be like, well, okay, I guess that's kind of cool. You can combine stuff. Well, what you can do with it, one, is like prove joint ownership of something. Like
Hmm.
none of us can produce a signature of this joint public key without combining both of our signatures. Secondly, it's fully asynchronous. So like if we're in a huge network of people and we're trying to produce a single aggregate signature, all the rest of the network has to know is you get the signature bytes, which is like 96 bytes, and it can represent arbitrary
Yeah.
participants having participated. So ETH2 does this at scale with a lot of what they do. So huge credit to them over the last few years for helping to productionize a lot of the libraries that people use for this.
Hmm.
Filecoin also it's very popular now in different
Yeah.
crypto projects. But it's a really cool way to just aggregate signatures and then show or authenticate that people sign things in a certain way. So
Awesome.
super useful for like group proof of participation.
Nice. And then one other follow-up question:
Mm-hmm.
Does Avalanche plan to support Move in the future?
Very good question. So this goes into what I was saying with the lower level and high level
Yep.
kind of concerns, right? So a prerequisite to that is most of the Move virtual machine is in Rust. So if we didn't have a Rust SDK, it wouldn't really be possible to do that. So our first step is just the Rust SDK.
Mhm.
And then we are very interested in seeing how people adapt it. I think generally speaking, maintaining a connection to another virtual machine that you didn't really write takes a lot of resources, and it's very error prone. And so what we'd like to see is to take the Rust virtual machine we have, or the Rust SDK we have built, and work with people that actually are developing Move and want to take it to different places to actually launch it as a subnet without us having to maintain the virtual machine.
That makes sense.
So are we interested in it? Yeah, definitely. And if you're interested in like kind of trying to create your own Move-based chain, we'd love to talk to you. And what I found out actually, for people that aren't familiar, is people talk about Move virtual machines just like they talk about the EVM. Like, you could take your contract from EVM, whatever, and deploy it somewhere else most of the time. That's not the case for Move. Every dialect of it has a very different feel, like a different feel. So you can't take a contract, for example, from Diem, apply it to Aptos. There's different frameworks and things going on with different object and how they like kind of give you access to different primitives. So it'll be interesting to see if there's also like a fork of things, because most people would have no idea. right?
Yeah.
You think move and you're like, all right, yes, whatever, move contract.
There are
Turns
many
out it's
different
not that way
flavors.
at all,
Yeah.
and it's very different. So
Yeah.
I'm curious to see how that plays out. But we think our expertise is much more in the lower level stuff and giving that to that ability to different people. But we're obviously watching it closely. So if we do see like a huge spike in transaction, we may try harder to get other people to work with us on
Yeah.
it.
And
But
then, so that's the virtual machine side. On the like programming language side, that's another conversation.
yeah, I mean, I think some people have considered like injecting move language into other virtual machines,
Mhm.
to which we'd be like, sounds complicated.
Yeah.
I feel like in that effort, you may get the worst of both worlds rather than like the best of both kind of
Hmm.
combined. So we'd be much more interested, I think, in helping people like have a dedicated virtual machine. If you wanted to, like, let's say, extend the subnet EVM to support move, we'd also love to, check that out. But
Yeah.
generally speaking, the move language in general, we would think would be best housed by a dedicated virtual machine for
Makes
it.
sense. Cool.
Yeah.
Awesome. Well, definitely appreciate your time. Maybe we can wrap it up. I tried to do spicy takes. I don't. I didn't really come up with any spicy questions beforehand. So maybe I'll just open the floor. Do you have like any spicy takes that you would say are contentious in the space, that, or like an unpopular belief that you hold near and dear to your heart that others do not hold?
Yeah, I think there's two interesting ones, maybe that I'll share. So I generally like to think I'm a pretty reasonable person. Like I try not to take part in a lot of the crypto Twitter like back and forth and stuff like that because I think it's very charged. I think you have a lot of people that are interested in certain things for any number
A
of
lot of
reasons.
bag bias.
Yeah, I think I mean for whatever reason, I mean, I think that different ecosystems have different people that will periodically share really hot takes about like other ecosystems in
Yeah.
general and stuff like that. So I try very hard to never really like I don't think it's a good exercise in many cases to talk specifically about other projects because there's usually a lot of context and things that I may not be aware of and stuff. So I do very very hard to try away from that. I do think about abstractions though, and how to use them. And one thing that's kind of been interesting to me is like lately a lot of interest has gone into the L2 story.
Hmm.
And the L2 story in for a lot of people have a lot of stuff to say here, so I'm not going to get too crazy about it. But generally speaking, I agree in general that in a perfect world, it is the most efficient way to process huge amounts of transactions, right? Like if you can have only one node processing everything, and then everyone else just like can kind of follow along or verify it and it's provable on a different chain, like that seems really cool.
Yeah.
However, I think there are two things about L2 that I think people don't really talk about much, and I think that will become very pertinent in the next 6 to 12 months. One, to regulators that I think maybe don't have familiarity with the nuances here. From the outside looking in, you got one node running on one computer that has a shit ton of state to it. Now, I think as soon as regulators get wise, I don't think they're going to care about the arguments that like it's decentralized because you can fraud proof it out. I think that there will be serious legal challenge to people that are operating different L2 batching engines. And I think it's one of the things where like with decentralization, it only matters when it matters.
Yeah.
And for L2s, it hasn't really mattered yet. Um, Likewise, I think people talk a lot about like L2s being like totally the future. We're already there. Like, let's get going. If you check out like L2 Beat, for example, and it talks about how far different L2s are along, a lot of them don't have a lot of the features that you would hope that like an L2 that you're putting billions and millions of dollars on would have. Like you
Yeah.
can't like exit. There's no like batch or recovery. And so I understand that it's a super important part of the story and everything like that. But I think it's interesting the narrative in the space really saying that like as far as I understand or what I see, it's like L2s are the thing, like they're here, like
Yeah.
ditch your everything else you're using in L2s only, without really talking about some of the nuance of like some of the risks that you're taking. Everything has risks. Like I'm
Yeah.
not saying that like there's other projects that you should pick instead or not, but it's just interesting that like it's still a very realistic concern that people haven't gone into.
I
And then
fully agree.
lastly, um, maintaining L2s with the fraud proof overhead is really complicated. because you have to make everything that executes on that L2 executable on another chain. And everything must be that way
Yep.
and executed by another chain. Otherwise, you can't prove the fraud proofs. So initially, people thought like, okay, we'll build these super targeted things and like we'll like kind of fork a ton of stuff to make it work. I think the general approach lately has been to not do that anymore and instead try and find like a generic compiler for like other chains, which I think is probably a better direction. But your trusted computing base to run that can sometimes be huge.
Yep.
And keeping that up to date and making sure it works as you make every single change to the upstream, like L2, that's a lot of, I think, complexity to worry about and think about as people go. And so I don't think we've had any cases yet because there hasn't been really any active fraud proof I've ever seen. But like, it will be interesting to see what if, your fraud proof prover fails and you don't know that until it's actually on the chain, right? So I just think that a lot of solutions that a lot of people are pursuing have a lot of complexity, and people tend to talk mostly about the potential upside of it rather than just, I think, kind of presenting everything. And I'm not one to say that subnets don't have different trade-offs as well. Like I'm not here saying like, L2s, like, forget about them. Like subnets are the way to go. Like subnets have different properties too. Like they're very tightly connected to Avalanche. Right now, most are controlled by an administrator. So, I'm not saying that like, strictly better or strictly worse. I just think there's interesting trade-offs that people will have to make for L2s to be successful. And I'm not sure that a lot of people are talking about those trade-offs.
I fully agree. I think it's funny. Yeah, the optimal design is like the single sequencer, but then to your point, if there's only a single one, there's some drawbacks. And then ultimately, if you start adding multiple sequencers, then you start having to do all the same things that you would with kind of a normal blockchain with like the data propagation and just kind of,
you end up like recreating a blockchain again, kind of, and then you're like, it reminds me of some other like kind of like state channel stuff that people tried to do for a while. It's like, oh yeah, we don't need the blockchain. Actually, we can just do everything in state channels, and then you realize that you're just building another blockchain on top of a blockchain with state channels. And so, like as you get into the multi-sequencer world, I think you kind of get into very interesting territory.
Exactly.
But with multi-sequencer in general, I think there's a large looming legal regulatory battle with L2s, and I'm very curious to see how it plays out. I hope hope innovation wins. But I've in recent weeks, it's certainly come under question whether or not that will always be the case. So, I think the last thing I'll leave on this topic with is subnets actually provide a lot of the stuff that you would need to build an L2, like a lot of the consensus stuff for you. So you could just have any number of sequencers contribute and then still produce a single state root that you could then checkpoint to an L1 if you wanted. So we haven't seen anyone build a subnet as an L2 yet on Avalanche, but we think that will happen. Maybe not next 3 months, but something that people will certainly look into in the next 12 months if they don't want to rely on their own security of the subnet, or they want to have like a recovery pattern where like maybe they do trust their own security, but in the case where shit hits the fan, maybe they want to have a checkpoint to recover to in the case that they're not maybe doing strictly fraud proving. So I think there's a lot of interesting collaborations here and there. I think we had the first L2 launch on Avalanche 2 weeks ago or so with Boba. Nice. That was always a funny narrative one. It's like subnets, L2s, like you can have L2s. Like, yeah, it's just a chain, right? Whatever people want to do. So
definitely. Awesome. Really appreciate your time, Patrick. Thank you again. I think a lot of people will enjoy watching and listening to this conversation. Any final parting words before we hop off?
No, I don't think so. I think we covered pretty much everything I wanted to kind of chat about. Thank you for hosting me. I always love doing this. This is my first podcast, so you never know
thank you for being the first.
Yeah. Well, not only the live thing, but like my first podcast I've actually ever done. So we'll see how that went. But thank you for the recommendation for the podcasting microphone.
There we go.
I got my first podcasting mic, but I think it's a really with the bear market and everything like that, sometimes it takes wind out of people's sails. But I do have to say that the parting thought I have is I've never been more excited to be in crypto and be part of what everyone's doing. I think that the things, not just us, but just across the space people are doing are so inspiring. It's great to be part of it, and I think that the cumulative work of all of us, will make massive changes in the world around us, and so it's just really exciting to see that really come to truth before our eyes. It's just super inspiring. So. Yeah.
I fully agree. I think that's a perfect place to end it on. Thank you again, Patrick. It was a pleasure.
Cool.
Awesome. We'll end it there.